So welcome everyone. My name is Rachel Watson. I'm Professor of Cutaneous Sciences here at the University of Manchester, and I'm one of the co-directors of MICRA. It's my real pleasure today to welcome you to this special webinar on our immunological defences, staying fit in the COVID world. So a few housekeeping rules to start off with. As you've entered the webinar, you'll notice that your camera and your microphone have been switched off. Please do keep these switched off. It just makes any buffering issues that we might have online much easier to resolve. There's also a chat function you can see at the bottom of the webinar screen. Can I encourage you to write your questions using that chat function and asking that you put the name of the individual you'd like to ask your question to in the chat question. We have three really excellent speakers today from the University of Manchester, all speaking in broad areas around the impact of COVID on the immunology of us and of our health. Our first speaker today is Professor Tracy Hussell. Tracy completed her PhD at the University College London, where she worked on H. pylori, and particularly as an etiological agent in human gut lymphomas. So after her research degree, Professor Hussell moved to respiratory medicine at St Mary's, and there she studied immunity and pathology to respiratory viruses. In 1998, she was made a lecturer at the Centre for Molecular Microbiology and Infection at Imperial College, and she was subsequently awarded a Career Development Fellowship by the MRC. So Professor Hussell was awarded a personal chair in inflammatory disease at Imperial in 2006. And she's worked to build a very vibrant research group studying immune health and its dysregulation in the lung. And we're delighted to say that we managed to tempt her away from London to come to Manchester. And Tracy now is the director of the Manchester Collaborative Centre for Inflammation Research, now known as the Lydia Becker Institute here. Our second speaker today is Dr. Mark Farah. Mark works in the area of photobiology and he's been involved in human research for about 20 years. He did his PhD and bachelor's degree in Leeds and has many years of postdoctoral research experience looking at the interactions of our skin with our environment. So Mark came to Manchester in 2009 to further develop his interest in photobiology, particularly the impact of sunlight on human skin. And this research looks at both the benefits and the hazards of sunlight exposure, particularly around vitamin D and the impact vitamin D has on our health and how that might alter as we age and also in different ethnic groups. So this work's been translated into formulating appropriate healthcare messages for different portions of our population, including national public health messaging. Our final speaker in this hour is Tjeerd van Staar. Tjeerd studied medicine and received his medical degree from the Erasmus University in Rotterdam in the Netherlands in 1987. He worked for many years as a practicing physician before joining a pharma company and working really as an epidemiologist, and is qualified as a person for drug safety. During this time working in pharma, he obtained his MSc in epidemiology from McGill University in Canada and was awarded his PhD in pharmacoepidemiology at Utrecht University in 1999. He's a very knowledgeable gentleman. He also has a master's in medical law and ethics and is director of the research of clinical practice research data link from the 2006 to 2014. In 2014, he became Professor of Health E-Research at the Farr Institute here in Manchester. He's published over 170 papers and is very well known in the area of clinical trials, pharmacoepidemiology and pharmacovigilance. He has been awarded several external academic affiliations to Utrecht University, to the MRC unit in Southampton, and to the London School of Hygiene and Tropical Medicine. In 2005, he was recipient of the Boyle Award of the European Calcified Tissue Society. So it's my real great pleasure to welcome all three of you today. Thank you for supporting our MICRA seminar. Our audience, I know, will be fascinated by what you say today. And just a reminder, everybody, that this webinar is being recorded and will be available for you to look back over and to share with your friends and families and colleagues early next week. So without any further ado, I'll hand over to Tracy, who will start our first talk. Thank you.
Just trying to move the slide on. Oh, there we go. Hello, invisible audience. It's a great pleasure to speak at this MICRA webinar. I'm director of the Lydia Becker Institute of Immunology and Inflammation, and since the COVID-19 pandemic struck us, the whole institute has realigned its research effort to understanding why this particular disease is so damaging. So why should we be worried? We've had coronaviruses in the past. We've had MERS, 2012, 2015, 2018. We've also had SARS or SARS-1 between 2002 and 2004. And along comes COVID-19, and suddenly, you know, everyone is extremely concerned. And they are right to be concerned, because what is happening at the moment is that we are being faced with a much more transmissible viral infection. So even though MERS had a case fatality rate of 37%, and SARS had a case fatality rate of 9.2%, less people were actually infected. The virus we have at the moment is much more transmissible, so you can see the difference between the number of cases between MERS, SARS and COVID-19. There is an extraordinary increase in the transmissibility of this viral infection. So even though it has a low case fatality rate, we've seen far more deaths with this particular strain that seems to have jumped from animal species. So that's why we should be worried, because of the transmissibility of this current strain of virus. So what did we do? Manchester rapidly formed what we call the CIRCO Consortium, which stands for the Coronavirus Immune Response and Clinical Outcome Consortium. And you can see that this drew together immunologists from the Lydia Becker, together with clinical experts at 4 major hospitals: Salford Royal, North Manchester, Manchester Royal Infirmary, and Wythenshawe Hospital. And these names just go to show the massive effort that was mobilized as soon as the coronavirus pandemic came to Manchester. We also collaborate with the BRCs and the National Institute of Health Research Respiratory Translational Research collaboration. This actually spans the whole country. So it really is a massive effort, and it's been very rewarding that all of this has come together so quickly and so effectively. So what have we been actually doing? We have been taking patients from all those hospitals and recruiting them on admission to hospital, and then we have been following them day by day. In some cases, in some patients, every single day we have received samples from them right through to the outcome of their disease. And what we're trying to address is, can we identify at early time points those patients that are likely to go on to develop a severe disease profile? And in other words, can we determine the people that we should be focusing on right from the beginning? We also want to know what is it about patients that makes them recover or makes them go on to require ITU admission and ventilation. So we've been taking samples day by day in every patient that's come into all of those 4 hospitals, and we've been analysing the samples fresh. They've been delivered to us by courier, and then we've been performing a multiplex analysis on the samples that takes into account every single immune cell and every single inflammatory mediator in the peripheral blood. So you can imagine, per patient per day, this ramps up to quite an intensive effort. Just have a drink. Now, I don't want to blast you all with immunology, so I'm going to show you sort of an overview of what is going on in the patient's blood. And to begin with, we're going to start with looking at healthy patients. They have a diverse range of different immune cells within their peripheral blood. These names may mean something to you, but it's very much populated by neutrophils, T cells, B lymphocytes, monocytes, with other smatterings of populations. And you don't need to be an immunologist to see that the peripheral blood of COVID patients is very different. And it doesn't seem to matter whether you've got a mild, moderate, or severe disease, there are profound alterations. So for example, if we look at these cell populations over here, on the left-hand side of the healthy patient, you can see that they're still present in the mild patients, though their position is slightly different. And as you progress through moderate disease and severe disease, these populations completely disappear. And you end up with a bloodstream that has up to 90% neutrophils in your blood, which is a very damaging scenario to be in, because neutrophils, you know, they're like the sort of fire of the immune system. They can produce many, many toxic mediators. So we wanted to understand better how patients end up in these different states. I'm not going to go into how we categorize the patients, just to say that it was based on their requirements for oxygen consumption during their hospital stay. So the more severe the disease, the higher the requirement of oxygen per litre per minute. Now, in general, one of the first things we noticed from analysing all of our data was that we could find indices that indicated that a patient was recovering. So in patients with moderate disease, we noticed that over time, so this is one patient on one day and the sample the next day, you can see that immune cell populations recover and neutrophil populations go down. And that's generally the same across all of these moderate patients. What happens is you have an improvement in certain aspects of your immune system and a reduction in the inflammatory components of your immune system. This doesn't tend to happen in patients that experience really severe disease. So you can see that this part of your immune system, the T cells, they really are not recovering these patients, which are all intubated, some of which who actually unfortunately died. So a really bad disease trajectory is when your immune system doesn't put itself back to normal and you end up maintaining this very high population of neutrophils. So we know now who is going to recover by the trajectory of their sampling on a day-to-day basis. We had some patients in the severe category who did recover, and you can see that even in these patients, their immune components restored themselves. And it's only in the ones that suffer significant long-term disease or mortality where you don't see that readdress in the immune system. So why do we end up with different populations of cells in the peripheral blood? What is this telling us about the disease process? Well, in order to recruit cells to the inflamed lung, the inflamed tissue sends out signals in the form of cytokines and chemokines that instruct the bone marrow what is required back at the tissue. And so mobilization from the bone marrow will depend on signals that actually come from the lung tissue itself. Now, if that organ is severely damaged or the infection is severe, then that signal is very strong, and so you get an outpouring of immune cells from the bone marrow that migrate to the lung. So what we're looking at is a snapshot in the peripheral blood, and that gives us huge indications on what is actually driving this disease process. So one of the cell populations that gets mobilized from the bone marrow by signals from the lung are the monocytic population. And these monocytes give rise to lots of cells that invade inflamed tissues. They're called macrophages and dendritic cells. And what we noticed is that these monocytes were displaying an abnormal phenotype while they were in the blood, in that they came out highly proliferating. Now, usually monocytes, when they come out, don't display this proliferation marker. You can see the control patients are down here, and you can see an increase in the proliferation of this population right across the disease categories. This one's the mild patients, this one the moderate, and this one the severe. So we know that we have an abnormal recruitment of monocytes that are still proliferating from the bone marrow into the diseased lung. We also know that the extent of that abnormality correlates very well with what the hospital actually measures as disease severity, and that's C-reactive protein, or CRP. So this is a very strong signal that something is going very wrong immunologically in these patients, and that what we're looking at in our readout will actually correlate with the hospital data. What we've also noticed in these patients is that their monocytes usually have quite significant levels of this protein here called COX-2, and that's very important for producing prostaglandins. And you can see the normal range that we have of COX-2 within different cell types, and the substantial reduction that we see in these COVID patients. Again, if we stratify the patients, then this signal goes down as the disease severity goes down. And you may think, well, why am I so worried about monocytes in the blood proliferating? Again, if you look at the patient trajectory, each one of these lines that joins these dots represents the trajectory of a patient. And you can see that those with severe disease in the black circles came in with really high levels of proliferating monocytes, particularly the ones that went on to develop this severe disease. So even though it wanes with time, when they actually come into the hospital, they have very high levels of this proliferation marker. You don't get that so much in mild patients where the levels are very low. So Ki67, they come in proliferating, and they're expressing very low levels of this protein that I mentioned before, COX-2. So this gives us quite a powerful indicator, actually, that we can identify patients on admission to hospital who are going to get a severe disease trajectory if they have high levels of this proliferation markers and low levels of this protein COX-2. So that's quite powerful. When patients come in, you can do a test that will indicate the disease trajectory, which means that you can focus on those patients who need the most care right from the time of admission. The other thing we noticed was that everyone keeps talking about this storm of cytokines that you have in your peripheral blood, and most of the therapeutics that have actually been tested are looking to neutralize that storm. So anti-interleukin 6, for example, is one thing that's been tested in clinical trials. But we noticed in patients in severe disease, the ones that ended up in the intensive care unit, that they actually had very low levels of these inflammatory cytokines, and these two other examples. And this suggests that you're most inflamed before you actually enter hospital. So your peak levels are observed on admission, but you're likely to have had this cytokine storm before you've even arrived at hospital. And so any therapeutic interventions would need to be done immediately upon admission to hospital. But in ITU, the disease is different, and this probably represents extensive lung damage that's preventing these patients from recovering rather than an inflammatory cytokine storm. So what's this got to do, you know, with MICRA and their focus? Well, obviously, most of the patients, the highest proportion of patients that come in are above the age of 65. And that's right across all of the disease groups. So this is national data. And if we look at the data from Manchester, you can again see that all patients are at least around or above 60. We have a 2-to-1 ratio of males infected compared to females. And that's particularly the case over here in the severe case where we're seeing a male dominance in the patients that end up there. But as your population ages, you end up sort of collecting comorbidities. So a lot of the patients who came in had an underlying condition of diabetes, interstitial heart disease, hypertension, COPD, asthma, and malignancy. And these tend to increase in frequency as you age. And you can see the proportions in the patients from Manchester who had at least one of these comorbid conditions. Obviously, some patients will have more than one position. So what do these results mean? We know initially that disease severity is driven by the innate immune system and the immune system in general. We have a cytokine storm. We can identify patients who go on to have a severe COVID-19 disease trajectory with this high proliferation, low COX-2. We know that the severe patients don't restore their immune balance between neutrophils and T cells. We also know that the cytokine storm abates prior to admission to the intensive care unit, which means any treatment needs to be done at ward level and preferably as close to admission as possible. It's quite remarkable that most of the therapies that are being tested at the moment have been determined by analysing archived frozen samples, whereas the Manchester cohort have actually analysed this fresh. And we've actually seen that the immune system is dominated by neutrophils, which you won't see from archived samples. And so we're proposing the focus on very different sets of immune therapeutics that stop neutrophils from being recruited in the first place. We're trying to stop their excessive release from the bone marrow. We're trying to stop their survival. And we're trying to neutralize some of the toxic products that are actually produced by the neutrophils themselves. So Manchester coming together as a team, working with clinicians, has really pulled out some novel, interesting data. And what we'd like to do looking forward is to work with MICRA to try and bring the aging indices into this system. We're currently pulling together all the data across the UK, and we will have the age of the patient. So hopefully with a bigger cohort, we'll be able to really nail it down to either gender, BAME effects, or the aging immune system. And I would like to stop there, and I'll hand over to the next speaker.
Thank you, Tracy. I must apologise, my internet is going in and out, so every now and again everyone freezes and then I realise it's me that's frozen. We have a couple of questions that have come through which I think probably are pertinent to answer now while we have you, Tracy. The first is around, when do we think that coronavirus actually arrived in Manchester? Do we have any indication from when people started to be, I suppose, coming into the hospitals that you're working with?
Well, we know that we've generally been about 2 weeks behind the wave that went on in London. So I would think possibly towards the end of March. I think the jury's still out on that, actually, because there may be a load of asymptomatic people out there that were infected a lot earlier that we don't know about. And understanding that asymptomatic, engaging that asymptomatic problem is really important, actually, because we need to know how many people have been affected. So we don't know the answer to that yet.
Okay. And the second point was really about sort of the pathomechanisms, I suppose, of the disease. So these are really helpful insights for working on the ground, but does it provide us with any insight into sort of, I guess, potential therapies? So either to prevent transmission of the disease. Clearly we know that social distancing works really very well. It's very effective. But is there anything else that we can gain from the immunological data that you're now getting to help influence, for example, virus, antiviral productions, etc.?
I think it's interesting that there are some comorbidities that have come to the forefront. So hypertension, for example, is quite a dominant feature on patients that are admitted, as is diabetes. So there's something specific about those particular conditions that make you more susceptible to severe disease with COVID-19. And what we're doing now is we're going out into the community and trying to understand, at the healthy state, what is the difference between the immune response in the blood of a diabetic compared to a non-diabetic, because we need to understand what's different about that baseline that then makes those patients more susceptible. So I think there's great hope in the future, mostly that we can select more appropriate therapeutic options for these patients.
Okay, thank you so much, Tracy. In the interest of time, we're going to move on to our next speaker, which is Mark Farah. But we'll come back and we'll have a panel discussion at the end. So Mark, thank you so much for coming and speaking to us today. Mark is going to speak to us around adequate vitamin D and the evidence that it may have a protective effect.
Thanks, Rachel. Yeah, so a lot of my interest is in vitamin D and how vitamin D levels vary in different populations. And so I've been looking at some of the evidence around a possible protective role in COVID-19 as well. So just to give a little bit of background, I'm sure most people are aware of the vitamin D is vital for bone health, for bone growth and function, and deficiency in children when they're growing can cause rickets. And in older children and adults, we have problems of soft bones. Basically, you lose your bone mineral density, which can leave you at risk of fracture. But there's a lot of other potential benefits of vitamin D that are now coming through in the scientific literature. Less so from direct intervention studies. It's more epidemiology and laboratory work. So particularly immune system function, and that's where the relation to COVID comes in. But vitamin D is also thought to be able to protect against certain cancers and also has an inflammatory role. But as far as where we get vitamin D from, our diet is actually very poor in providing vitamin D. Vitamin D is only really found in large amounts in oily fish, which in the UK we tend not to eat a massive amount of. There's a small amount in dairy products, and some foods are fortified, particularly cereals. But our main source is sunlight exposure, and it's been estimated that we get approximately 90% of our requirement from sunlight exposure. So at the start of this pandemic, there was worries about vitamin D because there's a whole number of factors that contribute to what we call our vitamin D status, so that the level of vitamin D in our body. And these are composed external factors here, which are mainly related to sunlight and the amount of sunlight we get, and are out of our control. So the season and time of day obviously affects the height of the sun in the sky and the strength of the UV that generates vitamin D in the skin. And then there's behavioural factors. So for example, how long you spend outside, whether you use sunscreen, how much clothing you're wearing. And obviously at the beginning of the kind of lockdown period, people were not going out as much. So the UK national guidance prior to this was as follows. This was mainly around oral vitamin D intake and use of supplements. So before 2016, actually there was no recommendation to take any dietary vitamin D. It was assumed that anyone aged between 4 and 64 could get all their vitamin D they needed from sunlight exposure. But there was a group of people that they deemed at risk and were recommended to take 10 micrograms of vitamin D a day. Those included people aged 65 and over, those who were at risk of limited sunlight exposure, either for health reasons or institutionalized, or for cultural reasons, didn't expose themselves to the sun, and also minority ethnic groups. The darker skin actually blocks the UV and prevents vitamin D production. And then in 2016, the government's advisory committee on nutrition reviewed the evidence, and they then suggested that everyone aged 4 and over should have 10 micrograms of vitamin D per day. And their aim was to have 97.5% of the population reaching a 25 hydroxyvitamin D level of 25 nanomoles per litre. So 25 hydroxyvitamin D is what is actually measured in the blood to determine your vitamin D status. And in the UK, we define 25 nanomoles per litre as the cutoff for deficiency. So below that, you are deemed vitamin D deficient. This level varies around the world in different countries. So the US, for example, doesn't set a level for deficiency, but they think you should have 50 nanomoles for what they call sufficiency. So this report was then translated into actual advice, which was those aged 5 and over should consider taking 10 micrograms of vitamin D a day in the autumn and winter, so not year round, unless you were still in one of these at-risk groups. So during the lockdown period, the NHS updated its advice to everybody, saying we should consider taking 10 micrograms of vitamin D a day because we're not getting enough sunlight exposure. And again, Public Health England echoed this message. Their chief nutritionist saying that we're spending more time indoors, and particularly those people that were shielding and not going out at all, were risking vitamin D deficiency. So again, consider taking 10 micrograms per day. Of course, in all of this, it always says consider, so they're not telling us to do it, they're just asking us to think about it as part of our daily routine. So I just want to show you how vitamin D status changes during the year. This is some data from Manchester from some studies we did about 10 years ago now. So this is a population of white Caucasian adults of working age, sort of 20 to 60 years, and we've followed them through the year, measuring their vitamin D status every month. And as you can see at the beginning of the year, in the winter, the levels here, so 25 is this deficiency level that I've talked about, and 50 is this level that some people think is sufficient, we should be aiming for. So just under half are above this 50 level in January, and there's a few people deficient. And then as the sun starts to get higher in the sky and we start to make vitamin D around the end of March, our levels increase, peaking around September. So by this time, most people are in this sufficient range with only very few deficient, and then it drops down again into December. So we locked down at the end of March, which obviously was here, and so we weren't getting this sun exposure to give this boost over the first few months of spring. So the question that's now arisen is, could vitamin D protect against COVID-19? There was a bit of an explosion in the literature of people giving their opinion on this and kind of advising that vitamin D could have a massive benefit. So I just wanted to go over some of the evidence for this. So the proposed evidence that people were stating was twofold. First of all, the mechanistic evidence. We know that vitamin D has a lot of modulatory effects. It can induce antimicrobial peptides, some of which may be antiviral. It can reduce pro-inflammatory cytokine production, and it can induce regulatory T cells, which again can down-regulate inflammation. The epidemiological evidence that people were stating was that the outbreak of COVID started in winter when vitamin D levels are lowest. They noted there were fewer cases in the southern hemisphere who were in their summer period. And they noted that there were more infections and greater severity, as we've heard, in older people and in ethnic minorities. So just going back to, again, some of the data that we've gathered in Manchester over the years on vitamin D status in different age groups. This is, again, white Caucasian groups. Here we have a group of adolescents, of 12 to 15-year-olds, 20 to 60-year-olds from the previous slides, and a group of 65 years and over. And as you can see, in January, we looked at the vitamin D status. Actually, the older group are not much different from the younger adults. You know, we don't see massive amounts of deficiency. We do see slightly lower levels in the younger group. And then going through to September, everyone kind of rises through the summer. And again, by the peak period at the end of September, there's not a massive difference between the younger and older adults. So we're not really seeing massively low levels of vitamin D in older adults. Now, the problem comes with ethnic minorities, and here we have our data again for the adolescent group and the 20 to 60-year-old adult group in the white Caucasian groups here. But our South Asian groups are massively deficient. So in January, we have our adolescents here and our working age adults, and the majority are well below this deficient level. And even in the summer, when we're expecting levels to have increased, there's still at least half of our volunteers that took part in the study in this deficient range. So they're pretty much deficient year round. So this was thought to be one indication of why those in ethnic minority groups may be more affected by COVID-19. So The NHS, in addition to recommending people take 10 micrograms of vitamin D, also put this in their statement, that there has been some news reports about vitamin D reducing the risk, but they don't feel there's enough evidence at the moment. And they also don't buy more than you need, because there was worries about panic buying vitamin D. But there is some evidence and some association studies. It's a bit early days really for COVID-19, because we've not had a chance to do any proper intervention studies. So some of the epidemiology is showing that lower vitamin D status has been associated with greater disease severity, although these are only kind of small studies and the evidence isn't overwhelming. And particularly this second study, which isn't actually published yet, it's in preprint, had vitamin D as one of the factors, but it was far outweighed by a lot of the other factors, some of which Tracy talked about, some of the comorbidities, and they had a much greater impact. There is some interest in the wider impact of vitamin D on respiratory tract infections, not just COVID-19. And there's been quite a bit of work done on this, and again some intervention studies, so we can actually see if intervening with vitamin D does help. One of the earlier studies in 2013 looking at vitamin D supplementation showed no effect on incidence or duration of respiratory tract infections. But one thing to note here is that they actually selected their study population to not be vitamin D deficient. And I think this is an important point to distinguish, because those that are deficient could well have issues with their general health, that those that aren't deficient will not. And again, I think that the strongest evidence to date has come from some very recent work looking at a meta-analysis of 25 randomized controlled trials. This is involving over 10,000 patients. And they concluded that vitamin D does reduce the risk of respiratory tract infection in all participants, albeit a small effect. But they saw a much stronger effect when they looked at the subgroups and those with vitamin D deficiency. So there is some evidence there that being vitamin D deficient does negatively impact on your ability to fight respiratory tract infections. So despite all this, just 2 weeks ago, Public Health England published some further guidance. They commissioned 2 reviews, one by the Scientific Advisory Committee on Nutrition that did that report a few years ago. They asked them to review the evidence of vitamin D and respiratory tract infections in general, and they concluded that the evidence does not support vitamin D supplementation to prevent respiratory tract infections in the general population. They also asked NICE to review vitamin D in relation to COVID-19, and this is where there is very little data at the moment, and I think I would agree that there's currently no evidence to support taking vitamin D supplements to reduce the risk or the severity of COVID-19. So just to conclude from the work that's been presented so far, there is conflicting evidence on the protective role of vitamin D, largely down to study design and patient selection, I think. The largest meta-analysis does indicate a protective effect, particularly those that are vitamin D deficient, but at the moment there are too few data to evaluate any impact on COVID-19. But by far the take-home message is it's still vital to maintain adequate vitamin D for our bone and muscle health, and potentially to start our general other well-being. I'd just like to quickly acknowledge there's a huge group of people in Manchester involved in vitamin D research, and this is just a few of them here. So, thanks very much.
Thank you, Mark. Thank you. We'll move on to our final talk, and then we'll be able to have a broader conversation. So if I can ask Gio to share his screen, and we'll start our final talk of today's session.
Okay, hope it's all okay. Okay, so thank you very much. Delighted to be here. I'm going to take a slightly different slant. I'm an epidemiologist. I've worked a lot with health data, primary care records, hospital data, and trying to figure out what's happening. So the first thing is to mention is, why do we need things like epidemiology? There was a provocative article in PLOS Medicine recently saying, is COVID-19, is that the nemesis of evidence-based medicine? And with that she means the focus on randomized trials as being the gold standard of research in clinical medicine. Is that actually warranted? Is that actually a good thing? I'm not saying that we do not need trials. Trials are very important to establish, for example, drug effects, but the tendency is they're very much one-dimensional. They ask very narrow questions to a very narrowly defined patient population. And if we're dealing with complex systems, biological systems, health systems, the clinical trial suffers because it has such narrow focus. And that's one of the main challenges. And I'll touch on that because that's what we see as well in clinical practice, that all the clinical trials we do not always answer clinical questions faced day to day by clinicians. Just two examples. One is a patient visiting a GP, has a sore throat, and the question is, should the GP give amoxicillin? Great, NICE has guidelines, so they say do symptom scores or count symptoms 1, 2, 3, 4. If it's more than 4, give an antibiotic. However, the patient may have used lots of antibiotics in the 3 years before. Is amoxicillin still effective? The patient may have developed resistance. There may be some other things happening. Is it a sensible choice to give another antibiotic? We do not know. Other example, which is quite typical, frail elderly patients typically have lots of conditions. They receive lots of medicines. NICE is well organized, lots of guidelines, but they all deal with disease and disease and disease. So you have a guideline for diabetes, guideline for hypertension. They have one guideline on frailty, but it's very thin. Basically, it says, look at your medicines, and that's about it. There's very little information about what to do with these very complex patients. And the underlying evidence base, these randomized trials, they often tend to exclude all these multimorbid elderly patients, because what do? They like to include only patients with the disease of interest, and that's about it, and all the others are excluded. So we have real challenges with having quite narrow defined research designs applied to a very diverse clinical situation. And I'll give you another example of this. So we did a project last couple of years where we looked at antibiotic prescribing in primary care. And primary care prescribes about 75% of all antibiotics. We're all very worried about overuse of antibiotics because there's a concern of antimicrobial resistance, that all the antibiotics will no longer be effective. It's basically a slow motion COVID pandemic. It's slow, it's developing, it's not acute like COVID, but it really may happen in 10, 20 years. And so, of course, the key is, are we actually using the antibiotics we currently have, which are very effective? Are we using them in the right way? So we did a lot of research around that, and basically the short answer is not really. So this is just an example of one of the things we found. Is we looked at patients who were prescribed an antibiotic, and we just counted how many antibiotics they received in the 3 years before. And we found that patients regularly get another course of an antibiotic and another one. So I'm not talking here about patients who need continuous antibiotics like cystic fibrosis patients. I'm talking about the patients who visit their GP once in a while and then they get another shot of antibiotics. You can see a distribution of the number of antibiotics, and you can see roughly that 20% of the patients received at least 9 courses or more in the last 3 years, which is a lot. So then the next thing we did, we tried to figure out, is it actually, is it safe and effective to give so many courses of antibiotics? And I tried to explain this graph. So you see 2 boxes. These are 2 different data sets. Both are data sets including millions of patients with data from primary care on antibiotic prescribing and the disease history, and also linked to hospital data. So we knew which patients went to hospital for infection-related complications. And what we then did is we identified a patient who received an antibiotic, and we then follow them in the 6 months after. So the x-axis is in the 6 months after. And what you could see that in the day after, in the first month, the risks were high, but then they dropped quite quickly in the black line. And that's actually what you expect. Patients are ill, they get an antibiotic because they have an infection, but over time in primary care, these are mostly self-limiting infections, they get better. And the black line were patients who have received not many antibiotics in the 3 years before. Then you go up, and all these are increasing levels of prior antibiotic exposure. So the blue line is these 9+ antibiotics. And we don't know the reason for that. One of the things, of course, could be comorbidity that could potentially explain, but we excluded lots of all the patients we could see with comorbidity, we excluded that, and we still left with a sizable group of patients who were using antibiotics. We couldn't see any major comorbidity in these patients, and they still had an elevated risk that stayed high over time and didn't go back to baseline. So of course, what do? I mean, there are two responses. One is the evidence-based response. Let's say I presented these findings to a committee with experts, and the chair at the end said, oh, what we need is a robust randomized trial, which is about the most stupidest things I've ever heard, because how can you randomize between having a history of frequent antibiotic use and a history of no antibiotic use? You can't randomize. But of course, there is a potential for concern, but saying, oh, there may be potential for confounding, therefore we have to ignore it, I think makes an error. So for me, I think the fundamental question is, we do it a lot in clinical practice, but actually what is the evidence that it works? What is the evidence of handing out antibiotic course after antibiotic course? What is the evidence that this works? And there's no other clinical evidence that suggests this practice. Plus, of course, we also have the serious risk of AMR. So in essence, I think we need more data to understand these so-called frequent flyers. What's happening there? Why are they taking so many antibiotics? And more importantly, what is happening that their risk of going to hospital, infection-related complications remains so high? Is it an underlying immunological issue, etc.? Is it an effect on the microbiota? I don't know, but it's something I think we need to look at. These are complex patients in the sense of the medication they've used, and we need to understand whether it actually works or not. Just on another thing is just to highlight on the type of data you could collect. So yes, we have good data on patients in primary care, some promises, but of course we would like to collect some more data. So I'm going to show you a little clip of a way of trying to collect data. So this is Evergreen. If you go to your primary care practice, you can tell your GP that you would like access to your primary care records, and then the GP then enters a code, and then on your mobile phone you get information, you get access to your full medical records, and therefore your medical record is transportable, so you can use it to go to the hospital and show all the medications you're on, etc. It also allows Evergreen to send you messages through your phone, reminds you of taking the tablet. So I'll show you a little clip about what they're doing, and there's a website at the end you can go to get more information.
The UK healthcare system is a complex machine made up of many different organisations. Getting it to work efficiently will improve outcomes for people, but you'll know how difficult this is. Many organisations have made progress with their internal systems, but linking to other healthcare organisations is incredibly challenging. The next generation of quality improvements and efficiencies can only come from improving the whole machine, to include social care, the private sector, gyms and others who provide health and wellbeing services. But how do we do that? We believe the answer is hiding in plain sight with the people we treat and care for. So Evergreen Life is turning the problem on its head and truly putting people at the centre of their own health and wellbeing. We know people want to take greater control of their lives, so we're enabling them to access and share their information with whoever they wish, providing a complete picture of themselves, enabling others to partner in the design and delivery of care. It's people who can make the machine work. Evergreen Life gives people the power to own, curate and share their own health record, while also helping them to live a healthier life. We signpost services from within the Evergreen Life app, so people remain well for as long as possible and recognise early warning signs when illness strikes, which reduces demand and improves outcomes. Powered health will improve health and well-being for all. Don't just say you're putting people first, do it. For more information about how Evergreen Life can help you transform your organisation, visit evergreenlife.co.uk.
Okay, yeah, sorry about the kind of the commercial, but I think it's useful to show kind of they have built a very interesting system, where an IT system, but also they're able to contact patients and engage them in the electronic health records and ask them questions, etc. Just some example of current work we've been doing, or Evergreen has been doing with us, is they're collecting symptoms, have been collecting symptoms on whether patients are suffering from COVID through an app, and they've been collecting that throughout the country. One of the challenges has been is that the government had their own NHS tracing app, so they weren't too keen on supporting this. But it's in essence, they have shown as this is a nice way of quickly collecting data on a large group of patients, members of the public. And these are some results where we basically, you can see here the rate of symptoms, COVID-related symptoms collected over time, and you can also look at different regions in the UK to identify any hotspots. Just to kind of move to the future, which is current work we're doing, which I think is particularly relevant, it's dealing with frail elderly. It's a project funded by Health Data Research UK, which is a National Institute on Health Data Analytics. And what we're trying to do in this project is we want to look at frail elderly patients and look at any disruptions in care, and basically analyze all the data from practices and feedback information to the practice and tell them you should look at those patients or these patients. This is good practice with respect to polypharmacy, etc. And we want feedback information. We also have built in a trial, so we're going to give different levels of feedback to clinicians and see whether one level of feedback is more effective than the other level. So for this, we hope to get access to very large regional data sets. So in Greater Manchester, there's currently lots of activity, ongoing to integrate records from primary care, from hospitals, etc., with purpose to kind of to better inform clinicians about what's happening in one side of the healthcare system and the other side of the healthcare system, and it's also a unique opportunity for research. Just my last slide. My own view is, yeah, a lot of problems are very complex, and there's not just one method. We really need a variety of research process. And I think one way, the only way, is that for patients with complex problems, we really need to think hard about how can we collect better data, engage them, and I would be particularly interested also find ways we can collect more lab data on those patients and trying to find actual insights. How can we help patients in day-to-day care better? That's it. Any questions for the panel?
Thank you. So if we can ask the panel to put their videos and their microphones back on. Thank you so much. Just to reiterate that this session has been recorded and will be available on the MICRA website from early next week. So yes, we've had a number of questions come through around COVID and also around interactions. What else might be possibly done to allow us to help understand this disease more. So the first question is to Tracy. So there's a question from Lisa who says that is asking around NSAIDs and what certainly what the impact of being on those sorts of drugs long term has been in the data sets that you've looked at.
Yes, I've been sneakily replying to just her, but for the benefit of everyone else. Non-steroidal anti-inflammatory drugs reduce COX-2, and we show that reduced COX-2 is a bad thing, and so it would imply that they shouldn't be recommended. Unfortunately, it's difficult to get at the patients who are already on these because they've all been self-isolating, and so they haven't really been infected in enough numbers for us to know if it has an impact, but we wait for wave 2.
Yes, and how likely do you think wave 2 is going to have, given the fact that the sort of the social distancing is being relaxed now, and we're seeing more people interacting on the streets and in a more social setting?
I think there is concern going forward that when the temperature starts to drop again in the autumn, October, November, that we may be faced with a mixture of influenza virus and possibly a resurgence of coronavirus, whether it will be the same one or one that's slightly mutated. So a wave is highly likely, but the composition of that wave we're not too sure about at the moment.
Okay. There's a question also about, I guess, the sex difference that we see in cases, so the differences between men appearing to have more severe disease than women.
Yes.
On that, sort of a sex bias, skewing within the immunology of an individual, with a population?
Yeah, again, the differences between male and female, people are noting now that there are differences in the immune response between males and females, and it's possible that males are more inflamed or they're quicker to inflame than females. But also there's an X chromosome linked idea that the regulators and receptors for the virus are actually on the X chromosome, and so obviously women have 2 of those and men have 1. So I think it's going to be a multi-component effect that we're talking about.
So could there be an argument for a beneficial effect for potentially reduced sex hormones in women that might be mediating the impact of the virus?
I think it's more that you would need to increase something in the males rather than decreasing something in the females. But the gender issue is really interesting about disease susceptibility in the first place. Once they're infected, they seem to have the same trajectory, but it's that actual initial infection that seems lower.
Okay. So maybe it's down to hygiene. That's a very controversial.
Well, there's a stand-call business, Sorry.
So I didn't mean to be facetious. So we also have a question coming around the electronic health records and how safe the data is when you are providing your data via a sort of almost a third party to allow us to look at details of large populations of individuals.
Yeah, I mean, the safety of digital data is of course paramount. I think in the projects we've worked with, they're all, the latest project, it was all within the NHS firewall. And this is all done with the consent of the practices. So we didn't get data the practice hadn't consented to, they were aware of it, they were aware of the purposes of the data and what we're doing with the data. And also it's important to highlight, we're not doing this to identify a particular patient. We're looking at this basic population level research. Yes, we may identify some areas where, let's say, the GP, the clinical practice, the practice has to look at, but it's their role then to identify, re-identify those patients and talk to the patient, etc. So there's very much a legal framework around it. There's also good practice framework around it, and most importantly, you need to be transparent what you're doing. So we were clear to the GPs what we were doing with the data. We also published information on the website, etc. So transparency is very important. But there's also a downside. Of course, you can lock up all the data, but as we currently see with COVID, there's an enormous need to better understand what's happening, who is at risk, etc. All these questions need data.
Yeah, thank you. We have another question regarding COVID-19 and the impact on ethnic minorities. So I think either Tracy or Mark could take that, looking at either the vitamin D angle or the more immunological angle for that.
Mark, I'll let you go.
Yeah, so from a vitamin D point of view, like I showed in my talk, we certainly the local Manchester population, it probably reflected UK wide and in most of Northern Europe. Ethnic minorities are known to have hugely lower levels of vitamin D, and this will impact on their health and probably their immune function as well. But I don't think there's been any connection specifically made between vitamin D and ethnic minorities and COVID-19 at the moment. I don't think there's enough data, but I think I know there are studies either underway or being planned looking specifically at this.
And from the immunology point of view, I think it's that, we've been noticing that there are some sort of social factors that are different with BAME groups, the size of their family, that they all live together, etc. So again, I think it's going to be multifactorial.
Yeah, absolutely. And one final question before we close the session, and I guess it's a question that we really don't know the answer to, is that once a person has had COVID, can they be reinfected? And we were talking offline, weren't we, Tracy, before the session started, about the patients that came in initially are now being readmitted 90 days later with similar symptoms?
Yes, we have got a number of our initial patients coming back in now, but what we don't know is whether they went out still with a viral infection and that has reactivated itself, or whether they've got a new one. We are now sequencing the virus from the first episode and this one to see if it is indeed the same one or a different mutation. But it's quite worrying actually that the same patients have started coming back.
So I think that's our hour pretty much up. I'd like to thank everybody who's joined this Zoom webinar over this period today. I hope you agree they've been 3 fascinating talks, which I've really enjoyed, and I've learned an awful lot about not being an immunologist. I think it's really helped me, and also the potential power of looking at the e-health records in pulling together all of this data that we have across Greater Manchester, the country and globally, with the ultimate aim of making our lives longer and healthier. So thank you everyone for contributing today. Thank you for your questions and for your engagement, and we look forward to seeing you hopefully in a more personal format over the coming months. So thank you so much. Bye-bye.
Bye.